So I already explained to you how to do the randomization, and I already explained how to partition the total sum of square into 4 components. And I already explained how to get the test statistic to test the hypothesis of no difference between the treatment mean. Now I want to show you an example for the Latin square design. So first you look at this example where in this example a researcher with a plastic firm wished to compare the tensile strength of plastic sheets manufactured by 4 different processing methods. So from this example, first you look at the example and try to identify which are the treatment. So I already mentioned that what effect that you want to see on the response variable or what you want to compare will be the treatment. So in this situation, we can see that the 4 different processing methods will be the treatment. And what is the response variable? The response variable is the variable that you measure at the end of the study. So at the end of the study, you want to measure the tensile strength and the tensile strength of the plastic. And here I also can say that we want to analyze the effect of different processing methods on the tensile strength of the plastics. So in this example, if you read carefully, you can see that the researcher feels that the technician who mix the formula and the equipment used in the manufacturing process will have an effect on the tensile strength. Meaning that here there are 2 extraneous factors that will affect the experimental result. What are they? They are the different technician and also the different equipment used in the experiment. So in this situation, you quickly come to your mind that there exists 2 extraneous factors that will affect the experimental result. So in this situation, he designed the experiment. The researcher designed the experiment in such a way that each processing method, that is each of the treatment, is assigned at random exactly once to each technician and each equipment. And the following table shows the tensile strength of the plastic sheet. What we want to know is whether this data show a significant difference in tensile strength of the plastic sheets manufactured by 4 different processing methods. So look at the data here. When you look at the data, these are the data. The inside here. These are the treatment, and also these are the technician, and also equipment are the 2 extraneous factors that will affect the experimental result. And if you look at this, if you look at this data, you cannot get directly from this data. You cannot get directly the treatment mean and also the treatment total. You cannot get directly from this data. So to analyze the Latin square design, you need to create another table here. So you need to create another table here where you have to get the treatment mean and also the treatment total. How to get the treatment mean and treatment total? So you refer to this table. Let's say for treatment A, then you add up A, 13 plus 13 plus where here 12 plus 14. So you get A, the total is 52. And similarly, for method B, you add up all the values of the treatment B. 12 plus 13 plus 13 plus 15, then divide by 4. So you get the total for treatment B 53 and the average is 13.25. And then once we have all this, all the values are available, then we are ready to compute the SSTOT, just like usual. SS treatment, we have seen this before. the treatment, SS treatment, minus the one in the bracket here, I leave it blank. What is this? This is just subtract 183 squared divided by 60. Similarly, for SS row, we do the same thing, and SS column, and finally the SSE. The SSE you get 2.37. Once you get all the SS, sum of square, then we try to get the mean square by dividing all the SS with its degrees of freedom. Then what I do now, I summarize the result in the analysis of variance table. So these are the summarized results in the analysis of variance table, where the degrees of freedom, t minus 1, 3, 3, 3, and errors t minus 1, t minus 2, we get 6. And this is the mean square, and this is the F statistic value. And these are the F value for treatment, for the column, that is equipment, and for the rows, that is for the technician. And then I compare, to make decision, I have to check, I have to look at the F table with 3 and 6 degrees of freedom. This value I get it from the F table, 4.76. And to make our decision, whether there is a treatment effect, column effect, or row effect, I want to compare this F with the degrees of freedom. I mean, for the critical value here. Now, let's say now, if I want to check whether there's a treatment effect or not, we want to know whether there's a treatment effect or not. Look at this F value, 58.5. Where does it lie? Is it in the acceptance or in the rejection region? So here, 58.5 is in the rejection region, because it is larger than 4.76. Since the computed value of F for treatment, 58.5, is larger than the critical value, larger is here. Reject the null hypothesis and conclude that the 4 processing methods have different effect on the tensile strength of plastic sheets. So we know that there is a significant difference of the different processing methods on the tensile strength of the plastic. We also are interested to know whether there is a technician effect or also the equipment effect. Now, if you look at these two, looks like the equipment effect, 6.4, 6.4 is larger than the critical value. So meaning that reject H0 for equipment effect, meaning that there is a difference between the equipment on the tensile strength of the plastic. Now, we also interested to know whether there's a technician effect or not on the tensile strength of plastic. So we look at the F for the technician, 3.075. Compare with the critical value, 3. Here, the value is here in the acceptance region, meaning that fail to reject H0. Fail to reject H0. So meaning that there is no technician effect on the tensile strength of the plastic. So here, we can see that from the result of the test, looks like only two factors that will affect the experimental result. That is the equipment and also treatment. But there is no technician effect. Is it wrong to include to do the Latin square here? No, it's not wrong. The answer is not wrong. Because this, if you see that here, the technician, there's no effect of technician on the strength of plastic. Meaning that here the researcher is very cautious. He is very cautious in planning the experiment. So he has used Latin square design to analyze his data. Because he is afraid if we do not include the technician, perhaps the test will be less sensitive unnecessarily. So he is very cautious in doing this experiment. Doesn't matter whether the technician or the equipment has an effect or not. As long as if you feel, if you feel that these two has an effect on the experimental units, has an effect on the result, then you just include them in the analysis and then use the Latin square design to analyze your data. Okay? So we have seen that Latin square design is good to be used to analyze the effect of treatment on the response variable. Yeah? But how about if Latin square is not necessary, but the researcher choose to use Latin square? What we have got to lose by doing this? Okay. So to answer this question, let us focus on the degrees of freedom of the error for Latin square and also for the completely randomized block design. Yeah. So here we have block Latin. Yeah. The question is, I already mentioned that the question is, how about if Latin square is not necessary, but the researcher choose to use Latin square design. Yeah? So Latin square not necessary, but he used this. Yeah? So what we have got to lose by choosing Latin square which is not necessary? Yeah? To answer this, we look at the degrees of freedom of the error term. Yeah? And we know that the degrees of freedom for the block is t minus 1, t minus 1. This is the degrees of freedom of the error. And for Latin square, the degrees of freedom of the error, t minus 1, t minus 2. Okay? Now, please note, a test is more efficient if it has more degrees of freedom of the error. Now let's look at this. If you use Latin square, which is not necessary, then we see how many degrees of freedom that you have lost by using Latin square. So, meaning that here you should use block, but you do not use block, you use Latin square. If you use block, which is necessary, the degrees of freedom will be more than this. Degrees of freedom of the error of block will be more than the degrees of freedom of the Latin. So we try to look at their different. So the different will be t minus 1 multiplied by t minus 1 minus t minus 1 t minus 2. When you subtract the degrees of freedom of the block design, subtract the degrees of freedom of the Latin square design, then you will get t minus 1. You can do it at home where if you subtract this, the final result will get t minus 1. So meaning that by using Latin square, which is not necessary, you have lost how many degrees of freedom? T minus degrees of freedom has lost t minus 1 degrees of freedom. So meaning that you have made the test less sensitive unnecessarily by using Latin square design. So what I just want to recap. What do I mean by the test is less sensitive unnecessarily? Meaning that the test cannot detect the differences between treatment mean when real difference exists. So meaning that we have made the test less sensitive unnecessarily when using Latin square when it is not necessary. Okay. So now next, let's say Latin square is necessary, but you do not use Latin square. Instead, you use completely randomized block design. So here, let's say, so Latin square, this is block. Okay. So block Latin square is necessary, but you do not use Latin square. Instead, you use block design. So you use block here. Here you use block. It's not necessary, but you use block. So what you have got to lose by choosing block when it is not necessary, but what is necessary is Latin square. Yeah? So to answer this question, we have to look at the partitioning of the total sum of square for each of these, for Latin as well for the block. For Latin square, the partitioning will be SS dot equal to SS dr plus SS row plus SS column plus SSE. This is the partitioning of the total sum of square for the Latin square. And for the block, SS dot SS treatment plus SS row plus SSE. So this row, or we can call it SS block. Okay. Now, since Latin square is necessary, meaning that there exist two extraneous vectors that will affect the experimental result. But you use block design. When you use block design, you only consider one extraneous vector that will affect the experimental result. Meaning that you do not consider the column effect. You do not consider that. When column effect, when there's another effect that will affect the experimental result, is not measured. It's not measured because you use block. This variation, when a column effect is there and not measured, this variation, which is due to column, SSCOL, the variation which is due to column not measured, then the variation is there. And the variation is there in the data. You do not measure. Then it has no place to go because you use block design. When there's no place to go, when there's no place for the column variation, then this column variation will go to the error. It will go to the error here. The error will become inflated. The error term will become inflated, become large. SSE become large. SSE become large, and MSE also become large. When MSE become large, then the F, because F is just MSDR divided by MSE. The MSDR divided by MSE. This is large, this is small. Then the whole thing will become small. Okay? When the F becomes small, the test will be insignificant. So the test will be insignificant. So here, the result of the test is insignificant, meaning that you have made the test less sensitive unnecessarily by not using Latin when it is necessary. So these are the consequences of not using the Latin square when it is necessary. You make the test not significant and make it less sensitive unnecessarily. Okay. Now, the final, another question arises. How about, if I'm not very sure, I'm not very certain whether to include, to use Latin square design or block design, if I'm not very certain on this. So, if we are not very certain of whether using Latin square or block design, always use Latin square and gamble that there will be another effect, that is the column effect, that will affect the experimental result. Always try to do that. If you are wrong, meaning that there's no column effect, the outcome of this, the outcome of the analysis is less serious. It is less serious than the first one. The outcome is less serious compared to when Latin is not necessary, you use Latin. Yeah? The outcome is less serious. Yeah? Because it is more serious if Latin is necessary and you will not use Latin. So always gamble and using Latin square when you are not sure whether to include another column effect in the analysis. Okay? And now I hope that you have understand this topic. And next topic I will discuss on the balance incomplete flow design. Alright? Okay, that's all for today.